Hey chemistry students, today's tutorial is going to be over ionic compound formation. So remember, ionic compound is formed between a cation, an atom that has given up electrons or lost electrons, and an anion, an atom that has gained electrons. So we are asked to write the chemical formula for the compounds that would be formed. So number one, we have magnesium and chlorine. So what we need to do is to figure out what the charge would be if they were to form an ion. So remember a periodic table trick. If it falls in group 1, it'll have a +1. Group 2 is +2. Group 13 is +3. Remember, group 14 was either +4, -4. I'm not going to focus on group 14. Group 15, -3. 16 is -2. 17, -1. And the noble gases, remember, do not form ions. So we're going to use this to help us. Okay, so first I need to find out what the charge would be of magnesium. Magnesium falls in the alkaline earth metal, so it would have a +2. I'm going to write that here, +2. Chlorine is a halogen, so its charge if it formed an ion would be -1. So when I'm forming a compound, I circle the number, drop the charges, whether that's physically marking them out or just forgetting about them, and then I crisscross the numbers. Now remember, if I'm putting a 1, I don't have to write that 1. So my compound formed between a magnesium ion and a chlorine ion would be Mg1. So I'm just going to leave it Cl2. All right, let's move on to number 2. So same thing as before. This time we have lead. Now remember, lead's actually a post-transition metal, but when you're looking on the back of our reference sheet, you may be able to see it right here. Lead can either have a +2 charge or a +4 charge. That's why ours was given to us. So this is lead with a +2 charge. Then we have this NO3 group. These 3 groups are polyatomic ions. So when I'm wanting to find their charge, I'm going to have to look on the back of my reference sheet. So I'm going to search for NO3 and I'm going to scan and I find it. So NO3 has a -1 charge. Now, same thing as before, circle the numbers, disregard the charges because our compound's going to be neutral, and I crisscross. So one reason why I put all of the polyatomic ions groups in parentheses is just so we don't get confused. So for example, with this first compound, Pb is lead and I just have 1, so it's understood if I leave Pb like that there's just 1 in the compound. Then I have 2 of this whole group. So I have 2 of this polyatomic ion in this compound. This is called a nitrate. So in this whole compound I have 1 lead and 2 whole nitrate groups. Alright, let's move on. Calcium. And then I have a CO3 group, which is called carbonate. So calcium's not polyatomic. It's not a transition metal, so I can find its charge with the periodic table trick. Calcium is also in the alkaline earth metal, so it has a +2 charge. CO3 for carbonate has a -2. So same thing as before, circle the numbers, drop the charges, crisscross the numbers. Now, when I write this compound, I'm going to have 2 calciums and 2 of this carbonate group. Now, since I have 2 calciums and 2 carbonate groups, this can also be written as so. So before I had a 2 to 2 ratio, so 2 calciums for every 2 carbonates, my anion, but that will actually reduce to a 1 to 1. Just to show, you could see a question like that pop up. Alright, let's go on to the very last one. So I have potassium, and then this is a chlorate group. This is a polyatomic ion. So potassium is not a transition metal. It's in the alkali metals. So I can use my periodic table trick. So here's potassium. So it's going to have a +1 charge. I'm going to look for the charge of this common ion on the back of my reference sheet. So when I do that, I search through. All of your monatomic ions are located in this column. Monatomic meaning silver, zinc, scandium. Polyatomic, most of these are polyatomic, like ammonium, for example, NH4. So there's more than one atom in that ion. So I'm going to look for ClO3, and I found it right here. So ClO3 with a -1 charge is called chlorate. So it has a -1 charge. So circle the numbers, drop the charges, and crisscross. So when I write this compound, I have 1 potassium, so I'm just going to write its symbol, and 1 chlorate group. Alright, continue practicing on your own, and thank you for stopping by.